So following on from the previous video, you were given the third derivative, and then your task was to find this. So the third derivative being equal to 6, then you can imagine it as this graph here. Let's imagine the whole situation in terms of motion. So here you've been given this graph here. Integrate it. It will give you your acceleration. Integrate it again. It will give you your velocity. Integrate it again. It will give you your displacement, and it's this graph that you're interested in. So you're interested in y of 10 here. Okay, so you've got to use the graph here, and then 10 is somewhere here. If you put 10 into here, then it should take you to here. Okay, so by using this graph here, we can work out this. But then we've got to find well, we've got to integrate it, and then integrate it, and then integrate it, so on. Okay, so given this, given this here, if we then given this here, the second derivative will be when you integrate this. So that would then take you to this. That would then take you to this. And now, hang on. Now, so what that means is, given that the second derivative equals 6, if you integrate it, then you're in a way your acceleration here, you will get a whole family of these lines where the gradient will be 6. You will get a whole family of them. But the thing is, by using the initial condition here, by using the initial condition, you can see that when y is 0, so when x is 0, y will be -2. So let's just say -2 is right here. Let's just say -2 is right here. So you, by looking at your initial condition here, you can actually see that you're interested in this line here. Okay, so hang on. So given that the second derivative equals this thing here plus c, okay, but then we would use our initial condition here, which was given to us in the question. So use this to find out your c. So put 0. Don't forget, when you put 0 into the second derivative, so basically put 0 into here, and then this is saying that the second derivative equals -2. So put -2 into this whole thing here. So that will then take you to this, and then from this you can work out your c. So c equals this, which would mean that the second derivative equals this. So by using our initial condition, which was given to us in the question, you can work out c. Okay, so overall, in a way, the acceleration equals this. So now to get to the velocity, find the antiderivative of this. So that well, the velocity will be equal to this, and then find the antiderivative. It will be this, but then we still got to find our c. So the acceleration being this here, if you integrate it, it will give you your velocity. So in a way, dy by dx is in a way like velocity. So what that means is, hang on. So what that means is, earlier in the question we were given we were given what? Sorry, hang on, bear with me. Yeah, we were given this here. Sorry, this should be a 6. We were given this here. Integrate it, it will give us this. Okay, and then now we integrate it again to give us the velocity. So when you integrate this, it will give you a whole family of these lines here. Okay, so hang on, let's go back a step. Let's go back a step. So we've worked out the in a way the acceleration, and then to find the velocity, we integrate it to give us this. But then we need to find out the constant here. So by using our initial condition, which was given to us as this here. So when you integrate this, it will give you a whole family here. But then by using this initial condition, which was given to us in the question, we can identify which one we're interested in. Well, when you look at this, if you integrate it, it will give you a whole family of these lines here. Okay, but the one we're interested in is the one we're interested in is this one here, because when x equals 0, then the whole thing here will be 0. So when x is 0, which would be here, then dy by dx must be 0. So we are interested in a line that passes through this point here. So we are in a way interested in this line here. Okay. So hang on. So from above we got to this stage here. From above we got to this stage here. But by using this we can work out c. So put 0 into here and into here, and then this here. Well, our velocity here is 0, so we can put 0 into this whole thing here. So that would then take us to this, and then c must be 0. So dy by dx equals this. Okay. So now if dy by dx equals this, then integrate it again. That will give you your y. So integrate it, and then integrate it will then give you this plus c. But hang on. So what was given to us originally was the third derivative being 6. The graph would look like this. Integrate it, it will look like this. Okay, and then integrate it again, it will look like this. And remember, we were interested in a quadratic that passed through the origin here because of the initial condition. Well, anyway, now integrate it again. It will give you something along. It will give you a whole family of these lines here. So when you integrate this, it will give you a whole family. But then by using the initial condition, if you look at this here, when x equals 0, we're interested in the one where it equals 6. So let's say 6 is here. So we are interested in this line here. So anyway, we got to we got to y equals this thing here. By using this here, we can work out c. Okay. So hang on. So now we need to put 0 into here, 0 into here. Okay. And then blah blah blah. C will be 6. If you put it into here, c will be 6. Now we've got our equation here. Y equals blah blah. So now that we've got y equals whatever here, we can work this out easily. So this equals hang on, let me think. This equals 906 here. Okay, so the answer overall will be 906 here. Okay, and if you get a graph plotter and plot this, so this was given to us as being equal to 6. So your graph will look like this. So when you differentiate this, it will give you in a way what would represent, in terms of motion, would represent the acceleration. So your acceleration would be like this. Differentiate this, it will give you in terms of motion, it will give you your velocity here. So your velocity will look like this. And then integrate it again. In terms of motion, it will represent your displacement, and it will give you a graph looking like this. Okay, and then if you look at the initial conditions that was given to us, so originally it was given this to us. If you integrate it, it will give you this thing here. It will give you the acceleration. So when you look at the initial condition here, this is your acceleration here, and then you can see that the initial condition, when x equals 0, the acceleration is -2. So this is by looking at this point here, it really indicates our initial condition here. And when you've got this, if you differentiate it, it will give you your velocity. But then looking at the initial condition here, the velocity is when time equals 0, the velocity is 0. So in a way, this condition here, this initial condition here is this point right here. Is this point right here, and then looking, and then when given the velocity, if you integrate it, it will give you your displacement. So if you look at the displacement, it will look something like this. But then the initial condition here. So when x is 0, the initial condition is 6. So when x is 0, the displacement is 6, so it's right here. So you can think of this this initial condition as being this point here. When x is equals 0, y will be 6. So you can think of this as being this point here. Okay.